Cameron here, and what we're going to be doing today is we're going to be finishing up the second half of this lab, and we're going to be covering non-standard drawing views. So in our last video, we went ahead and modeled this pulley wheel. So what we're going to do today is we're going to go ahead and put this into a drawing, and we're going to cover different drawing views. Now, before we go ahead and dive into that, we're just going to cover these briefly. So, when it comes to non-standard drawing views, why do we have these? Well, first we need to ask ourselves, how many views do you need on a drawing? In order to convey the full sense of this part, how do we do that? Now, we know that we have our 6 traditional orthographic views. Our front, right, and top, bottom, left, and back. Now, there are times when those are plenty, right? Sometimes we just need a front view, sometimes we need a front and a right side view. The number of views that we put on our drawing is going to depend on the complexity and the geometry of the part. But there are times when these 6 views don't quite convey the entire shape. Now, in that case, that's where we resort to non-standard drawing views. And the main one we're going to talk about is what we call a section view. Now, the best way to visualize a section view is imagine you have a big knife and you're just chopping your part in half. And then you're opening up to see the inside of the part. That's really what a section view is. We've got our piece here, we chop it in half with a big knife, and then we can open it up kind of like a coconut, and we can see the inside of it. Now, when we do this, what we're going to do is we're going to have a cut line, we're going to have a parent view, and then we're going to have our section view. And you can see right here in this example why we would do this, because we have this internal cavity here, and from the outside, or really any other view, we're not going to be able to see the details of this cavity unless we physically cut it in half. So what we're going to do, we're going to have our parent view, cut it with a section line. That section line is going to be denoted with a couple of arrows and a couple of letters. Now, whatever way those arrows are pointing, that's the half that you're looking at, right? So in this example here, we're looking in this section view here of this top half, not the bottom half. So the direction of those arrows is important. You can see more examples of why we would do this. One thing we don't want to do when we create our drawings is dimension to hidden lines. And we'll cover an example of why we don't want to do that specifically. So the only way we can dimension this detail is with the section view. Now, it also comes in handy when we're building assemblies, and we're going to touch on that in a week or so. Specifically in this example here. Now, let's see if I can't blow this up here. Because this solenoid, right? This has a whole bunch of internal pieces that aren't visible from the outside. So, in order to see inside there, we have a couple of options. One we'll talk about at the end of the video. But one of them is a section view. And when it comes to sectioning assemblies, you'll notice that our views are crosshatched. Now, this crosshatching serves to not only distinguish parts from one another, but also serves to help identify what the material of those parts are. You can see we have different crosshatching for steels, irons, coppers, rubbers. So at a glance here, we can tell that this is one material, this is another, so on and so forth. And in this view here, we've got our section line. We're seeing all this internal detail that we can't really see otherwise, like bushings and pins. And this is a great example here. We wouldn't be able to see these 2 internal bronze bushings in this assembly if it weren't for a section view. So section views in general, it's essentially just chopping your piece in half so that we can have a look inside. We also have other drawing views. We have detail views, broken sections, alternate positions, auxiliary, and exploded views. And we'll do a quick summary of each of these. A detail view. This is probably the second most view you're going to use. You can think of this kind of like a magnifying glass. What we're going to do is we're going to take our view, all right? We're going to circle it, and then that's going to create a separate view. It's going to blow that detail up. In this case right here, if we want a better look at this, or if we want to dimension this, this is really kind of hard to come in and dimension in this scale. So what we do is we circle this, give it an identifying number, detail B, and then we can blow that up to whatever scale we need. Now, we can also stack these views, right? So if we have a section view, and we want to see some detail in this section view more clearly, we can go ahead and blow up a portion of a section view. Now you'll notice section views, detail views, any type of auxiliary view is going to come with this little identifying tag. Detail C, C, section view BB. These tags must always stay with the view. That way we can trace them back. If you just have this view sitting here in space, there's no telling what section or what detail that is of. Especially when your drawings get really complex and you have a lot of views all over the place. So always keep this little identifying tag with your view. Now, a broken out section. This is kind of like a section view that doesn't have a separate view. And you'll see what I mean here. What a broken out section is essentially taking a hammer and chipping away a portion that we identify. So rather than creating a whole separate section view, we're just chipping out a corner here. Now, why would we want to do this instead of taking a whole section view? Well, in this case here, right, we just want to add detail to these one or two nodes here, these one or two features. We want to add a dimension on here, and since we can't dimension to a hidden line, this doesn't really warrant an entire section view being done. So what we can do is just chip out this little section here and here so that we can have a peek inside. Now the reason why we don't dimension to hidden lines specifically is in a case like this here, right? You can see all this internal geometry here. And there's no sense of depth here. So if you were to dimension to any two lines in here, right, you would have no idea what those lines actually are in the grand scheme of things. So to avoid confusion, we just don't dimension to hidden lines at all. And in this case here, these hidden lines aren't really serving a purpose to us, and we would probably turn hidden lines off in this case. So another view is similar to that. It's called a broken or an interrupted view. Now the reason why we have this is for large, long parts, like this piece here. Let's imagine this was a 4-foot, bolt, right? All this material in here isn't giving us any new information, right? There's no need for all this to be on a drawing. So what we can do is we can break this, remove this interior section out, and then just collapse the ends in on each other. And when we see this on a drawing, we know that this is indicative of a longer part, but it's all the same. So what we do is we truncate this to shorten it up to fit on a standard drawing. You'll especially see this with plumbing drawings, right? If this was an 8-foot section here and a 1-foot section here, our drawing would be really uncohesive. Our drawing would either have to be massive in order to fit all the detail on, or some of these details would just be shrunk down too much to the point that they're not usable. So rather than doing that, what we do is we just remove the extraneous sections of pipe. Now when you come in here and dimension this, so if you were to put a dimension between this surface and this surface, it would still read that 8 feet, and this one would still read 1 foot. It doesn't change the dimensions, it changes just the scale of it on the drawing. Another view that we'll talk about more when we start building assemblies is alternate position views. So if you have an assembly that moves, specifically in the case of this clamp, you will want to sometimes dictate the alternate positions that this clamp can be in. What can happen a lot of times is if you just have this static drawing right here, and this part is going in an enclosure, what can happen is sometimes people can build an enclosure that will fit it when it's in this closed portion. But when they go ahead and try to move this in the real world, when they try to build this, they'll notice that because they built it to the closed scale, and they didn't have any reference for it when it was open, that they can't actually use this clamp in there, right? It'll hit the lid of the enclosure. That's a common issue in engineering, right? A lot of times we're designing fixtures and enclosures and pieces with parts that we don't actually have on hand. So knowing the full scale of the dimensions when this part is in its extremes is important to us. We also have an auxiliary view. Now, the best way you can think about this is a section view that doesn't actually cut our piece. So we apply it just the same way. We've got our section view line right here, but it's not actually cutting anything. And what it's doing is it's giving us an additional, essentially, camera view in whatever direction we need. Now in this case, the reason we're doing it here is so that we can look at this surface here perpendicularly. If we were to look at this surface from the right or from the top, we would be seeing this detail here at an angle. But if we can put our auxiliary view at an angle, we can look at this straight down, and what this allows for is more accurate dimensioning. And then finally, we have what's called an exploded view. And if you have ever seen IKEA furniture, you have seen an exploded view. This view right here, we have a pretty decent sense of everything that goes into it. But some of these finer details get lost. So what we can do is we can take this and explode it out so we can see all the parts that go into this wrench. And it lays out the order and the assembly process generally of how these parts go together. That way, we have much better idea of what goes into this than we would from this view. So let's go ahead and use this. Let's go ahead and put some of these views into practice. So what we can do first is we can go ahead and open up this pulley wheel. And then like we usually do, we're going to go ahead and create a drawing from it. So we're going to go to Make Drawing from Part. And what we're going to do is we're going to put this on a B format paper. So we can go to Properties and set this to ANSI B. Now since we modeled our part in inches, we want to make sure that our drawing is dimensioning in inches. Now before we go ahead and start putting views on this, what we're going to do is we're going to set our drafting standard. To do that, we're going to come up to Options, Document Properties, and set our overall drafting standard to ANSI. Now we can go ahead and start placing views on here. We're going to come up here to our View palette, and we're going to select our right side view. And we're just going to click and drag that on. Now, since this view is a little small, we're going to go ahead and blow this up, and we're going to set this to 1:1 scale. That looks pretty good. Now, you'll notice here, if I go ahead and put in my right side view, we're not seeing all the detail inside here, right? Because it's blocked by this fatter outer rim. So what we're going to do, rather than putting a right side view, put in a section view. To do that, we are going to come to View Layout and then select Section. Right now, it's giving me a horizontal section. On my left-hand side, I'm going to change my cutting line to vertical. It's going to give me a vertical section. I'm just going to put this right in the middle. I'm going to click, and I'm going to select OK. Now what that's going to do is it's going to cut it and give me this section view. I'm just going to drag this off to the right-hand side. And you'll notice it has that section AA tag. AA. So that looks good. What we're going to do now is dimension this. Now, in order to dimension this, we could go ahead and put in all the dimensions manually. What we're going to do is we're going to have Solidworks dimension this for us. For that, we're going to go to Annotations, and we're going to select Model Items. Under Source, we're going to select Entire Model, and then we're going to select OK. And that should run through here and throw in a whole bunch of dimensions. Now, we have to be careful doing this, because it doesn't always dimension everything perfectly. And you'll see what I mean in just a second. So what we're going to do is we're going to start on this section view. And the first thing you'll notice, do you see how it's dimensioning this 1/2 inch, this 1/8 of an inch, and this 3/4 inch? What it's doing is it's dimensioning those to that imaginary center line. Now the problem with that is, that's not really a useful dimension to us on a drawing. Right? We don't care what it is to half of the part. We want to know what the whole width is. And this is one of those issues that you run into using this tool. So what we want to do is we want to delete these. And then we'll go ahead and put those in manually. So we'll grab Smart Dimension and then just dimension the overall width. We'll dimension the width of this skinny portion here, and the width of the top. So that's one of the issues you have to watch out for. The next thing we want to do is just take all these dimensions and space them out. Make them so that they're coherent. A drawing is only as good as it reads. If our drawing is bunched up and it's hard to read, it's essentially useless to us. So what we want to do is just take a second, organize these dimensions so that you don't have to hunt and try to find the dimension that you need. And something like that looks good. Now when we come over here to this front view, this is another place where we run into that same issue. Because if we look here, what it's doing is it's dimensioning the hole pattern spacing for just one of these holes. And it's dimensioning it to an imaginary center line. Again, that's not really useful to us. So what we're going to do is we're going to delete this. We're going to grab Smart Dimension. And we are going to put in a dimension from one center cross to another. Do you see how it gives me that 60-degree dimension? That looks pretty good. Again, we're just going to take these dimensions and organize them so that it looks tidy, it looks coherent. One thing we can do here is we can take this 1/2 inch, we can click on that, and then on our left-hand side we have this dimension text. In front of this mod diam, we're going to put 6x, because we have 6 of these holes. We can do the same thing with this 60 degrees. We're going to click on that 60 degrees, and then we're going to put in EQ SP. And what that is short for is equally spaced. So what it's saying is that all of these holes are 60 degrees equally spaced. And that looks pretty good. So at this point, the actual dimensioning on this is pretty much complete. What we're going to do is go ahead and edit this title block. Now to do that, what we're going to do is find some free space on our drawing, right-click, and select Edit Sheet Format. Our drawing disappears, and that's fine. We'll come back to that later. But what we're going to do is we're going to go ahead and edit this in the standard fashion. So in our first block here, we're going to hunt around towards the center till we see that little A pop up next to our cursor. We're going to double click, and this is where we enter in Wentworth. Our title for this can be 4-inch pulley. Something to that effect. It's not too critical what you call this. Our revision always starts out as revision 1. Drawn by, you're going to put your initials in here, and today's date. Over here for our tolerances. For fractional, we can set that to 1/16. Machine, we can set that to 1 degree. And bend, we can set that to 5 degrees. Two-place decimal, 0.05, and three-place decimal, 0.003. Interpret geometric tolerancing per ASME Y 14.5. For material and finish. Now, before we put our actual material in here and our finish, what I'm a fan of doing is putting in a note here called C notes. And what we're going to do is put in a separate notes section. And I'll explain why we do this. And then, as always, we can delete this garbage. There we go. So that is our completed title block. To get back to our full drawing, what we're going to do is find some free space, right-click, and select Edit Sheet. There we are. Now, like before, or like I said earlier, we're going to put in a note here called C Notes. So we have to put in that notes section. To do that, we're going to come up to our top left-hand corner. Under our Annotations tab, we're going to grab our Note tool. And we're just going to click and set that down. Now, how you format your notes is going to vary depending on what company you go to. In general, it's going to be something to the effect of notes. And then we list them in terms of importance. And our first note is almost always our material. Now, I believe in our case, we set our material to be ASTM A36. You guys can correct me if I'm wrong on this, but I believe it was A36. Our second note is going to be for surface finish. Now, surface finish is how well our surface is machined. If you guys have ever run your finger over a machined part, you can sort of feel that thumbnail catching on the ridges. This is what we're trying to control here. A good general surface finish is anywhere from 64 to 128 microinches. So we're going to spec it out towards the higher end, 128 microinches maximum. Our third note is going to be for finish. This is anything we want applied to the surface, like paint, powder coat, anodizing, chrome plating. We don't want any, so we're going to specify none. And then finally, our fourth note is going to be deburr and break sharp edges. What they're going to do is they're going to go around with a file or some sandpaper and just take off all the burrs, any sharp corners. That way we don't have to do any cleanup work when we get this part. And that looks good. We're just going to position that in our top left-hand corner. So at this point, our drawing is complete. So what I would like you guys to do is to save this, and then save it as a PDF. And the PDF version is actually what you're going to be uploading to Blackboard. So if you guys have any questions on this, please let me know. And as always, have a nice day.